We're going to be talking about inequalities, and we'll do a series where we'll start with the basics of inequalities and solving and graphing them, and then we'll move on to more complicated topics. This first one though, our objective is I can solve and graph inequalities. First of all, let's just talk about the number line itself. If we have the number -3 and 2, x equals -3 is a solid dot on -3, and x equals 2 is a solid dot on 2. Now, if I notice that -3 is to the left, so it's less than 2. Now, if I multiply both sides here by a negative, it reverses the inequality relationship. If I multiply -3 by 2, I get 3, which notice x equals 3 is a solid dot over here. And then I multiply 2 by -1 and I get -2, and they flip spots on the number line. So now the inequality is a greater than. 3 is greater than -2. So one of the basics that you need to know about inequalities is if you multiply or divide, either one, multiply or divide by a negative, that's the critical part. Then the inequality symbol reverses. So if it was a less than, it becomes a greater than. If it was a greater than, it becomes a less than. It reverses direction. Now that otherwise, the inequalities follow the same exact rules as real numbers for equations, for equal signs. You can always add to both sides and the inequality stays the same, or you can multiply or divide by a positive and it stays the same direction. It's only when you multiply or divide by a negative that it reverses. So that's a critical thing to remember when going through these problems. So let's look at some inequalities. This is saying if we've got the set of numbers x, so x is our variable, greater than or equal to 4, that makes sense that the equal to, the or equal to part, since we have x equals, we do a solid dot, we're gonna have a solid dot here. So the or equal to gives me a solid dot, whereas if I don't have the or equal to in my inequality, it's going to be an open dot. Okay, so if we have a greater than, or greater than, or less than, that's going to be an open dot. Whereas we have a greater than or equal to, less than or equal to, that's going to be a closed dot because of the or equal to part of it. The next part that you need to know about these, notice that it's the direction. Greater than, that means we're going to go to the right. That's if the variable is on the left-hand side. So if we've got when we have the variable on the left, if we have a greater than or equal to, or a greater than, you shade to the right-hand side. If you've got a less than or a less than or equal to, you shade to the left. It follows the direction of the inequality symbol if the variable is on the left-hand side. Now, the variable could be on the right, and I'll show you an example of that down here. It's just kind of a conventional thing to always put the variable on the left so we can follow those types of rules. Okay, so let's do this problem down here. First of all, I'm going to distribute through this negative. So I'm going to have 4x minus 2x plus 3 is greater than 13. Now I'm going to do 4x minus 2x, I get just a 2x. I'm going to subtract 3 from both sides. Subtraction does not change my inequality, so it's just going to be this same greater than is greater than 10. And now divide by 2, x is greater than 5. So down on my number line, you don't have to number a lot of numbers, but give a few. Here's 5, and I'm going to do an open dot on 5 and to the right because it's a greater than symbol. Let's do this one. On this one, my first step is I'm going to subtract 19 from both sides. So I'm left with a negative 5x is greater than or equal to 10 when I subtract 19. Subtraction does not change our inequality symbol, but now I'm going to divide both sides by negative 5. By dividing by a negative, we've got to reverse our inequality symbol. So when I do that, I'm going to have an x here. 10 divided by negative 5 is a negative 2. Reversing the inequality gives me a less than or equal to. Now I can graph that. So down here, I'm going to start here at 0, go negative 1 and negative 2. And then that's going to be a closed dot because of the or equal to part of it. And then the less than tells me to go in this direction. This last one here, I'm going to subtract 8 from both sides, but notice the variable's on the right-hand side, so 7x stays here. Subtraction does not change my inequality. Subtracting 8 from negative 20 gives me negative 28. Divide by 7, dividing by a positive does not reverse my inequality. It keeps it the same. So we have just an x here. Dividing by 7 gives me negative 4 here. And I have the greater than symbol. But if I read it from the x, I'm going to say that that's an x is less than negative 4. So you can read it from the x in that direction. Or if I want to go ahead and write it with the variable on this side, notice that the inequality symbol direction has to follow the x. It's pointing toward the x, so I'm going to reverse it in this case. So if you swap sides, because order makes a difference with inequality, then that inequality symbol also has to swap sides if you switch their order. So let's go ahead and graph that. Here's negative 4. It's not or equal to, so I'm going to do an open dot and then graph in that direction. So when doing this, just as a reminder, follow the rules we have for solving, just like we did with equations. We'll do it with inequalities. The exception is that if you multiply or if you divide by a negative, that's going to reverse the inequality symbol. Then also make sure you know when to do a closed dot when there's the or equal to, an open dot when there's not an or equal to on it, then which direction to shade, and then solve your inequalities and graph them.